Welcome to all of you on this webinar. The focus of today's broadcast is the implications of two major climate change reports from 2018, both linked in the webinar information you've already received. Since the release of those reports, there have been additional reports, all of which reinforce the message that there is an urgent need to act to address this clear and present threat to the health and well-being of our ecosystem. The League of Women Voters of Massachusetts is honored to have Professor Michael Oppenheimer with us today to discuss the implications of these recent reports. Professor Oppenheimer is an internationally recognized authority on climate science. He has been a long-time participant in the UN Intergovernmental Panel on Climate Change and a lead author of several UN IPCC special reports, and that's a very short list of his experience and expertise. As important as his qualifications to speak on this topic, Professor Oppenheimer is able to convey key findings of complex scientific reports for the general public, a necessary ingredient for awareness and action. Welcome, Michael. We are so grateful for your work and so pleased to have you with us today.
Thank you, Lorna and Karen. I'm happy to be here too. Over the years, I worked with the League at the national level and a couple of the state organizations as well, going back to the days I spent with the Environmental Defense Fund. And it was always a fruitful relationship. What I hope to do today is summarize briefly the key points of the two reports that came out this fall, the report of the Intergovernmental Panel on Climate Change, the IPCC, on warming of 1.5 degrees Celsius, and the report of the Fourth National Climate Assessment, which is a US government report that's issued every few years, this being the fourth one. I'm going to start by giving you the headline messages and then go a little, and those are my view of the headline messages, of course. And then go into some of the details and conclude with briefly outlining my own personal views, partly as a scientist, but mostly as a citizen, on what I think can and should be done about the problem. So let's get going with the next slide. So the two reports, and combined with some other things that are going on, namely a number of severe attention-grabbing climate events like the fires in California and a very active hurricane season in terms of categories 4 and 5 hurricanes, appear to have a marked effect on changing public attitudes over the last few years. I think, by the way, as an amateur political scientist, it's worth noting that a president who doesn't accept the science of climate change has had the sort of unexpected counterintuitive effect of polarizing the public yet more, so that people who might have been leaning toward some belief in climate change seem to have moved over towards a stronger worry about the problem, and probably some of those who were aligned with the forces not believing in climate change tilted a little more the other way, and that's also contributed, I think, to a gain in strengthening of beliefs about climate change. So what did these reports, first, what was the point of these reports? The IPCC report was actually commissioned by governments, and it's supposed to address a long-standing question going back to the UN Framework Convention in 1992, which is the original International Climate Agreement. And part of that convention states an objective, which is to avoid a quote-unquote dangerous warming of the climate. We'll get to what might be considered dangerous a little later. But the report, basically, this report is supposed to answer that question: how warm is too warm? What is dangerous? And what is it we can do about it? The report was requested by governments after the 2015 meeting, which led to the Paris Agreement, and which is now the international framework for governments to deal with the problem. And governments made, on a voluntary basis, commitments to certain efforts to start reducing the emissions of the greenhouse gases which are causing climate change and global warming. the report is supposed to address both the benefit and the feasibility of attaining the current view in the scientific and on the parts of governments as well as to what a dangerous warming is, namely about 1.5 or 2 degrees Celsius warming. You can double that to get it in Fahrenheit above pre-industrial temperatures. Now, we're already about a degree of warming above pre-industrial temperatures. So that right away tells you there isn't much headroom left, and that without a thick report, you can tell it's going to be a difficult job to avoid this terrain of danger. It's worth saying at the outset that there's a lot of uncertainty about exactly what temperature triggers what impact and what impact really will be dangerous, in the sense that human beings have a fairly large capability to adjust to climate changes, at least people in wealthy countries. And therefore, one should regard all of the statements that I'm going to give you as being characterized by uncertainty. And it doesn't mean that if we're 1 and 1.5 degrees and we move up to 1.51 degrees that the world is over. That's not the way this problem works. The fourth National Climate Assessment, again, a US government document, is a comprehensive examination of current climate changes and climate changes that will occur in the future and how they might impact the United States. And also, it's about what we would need to do to adapt to those climate changes to minimize damages, and what emissions reduction strategies and other strategies could be taken to avoid that level, to avoid certain levels of warming, which would bring about these impacts. So when you put these reports together, you get a global picture of how much warming is too dangerous, how much action is possible by governments to avoid that warming, or whether we are going to wind up in the danger zone and have to be ready for that and increase our game, up our game on adaptation, and also specifically about impacts in the United States and what the United States needs to do. So let's move on to the next slide. I'm going to skip to the bottom lines first. And the most important one is the danger is already here. By many measures, for many people around the world, it's already a bad climate. There's too much extreme heat, too much humidity. These have already been increased by climate change, probably been an increase in heat-related deaths. And we could also point to things like the wildfires in California as events which were probably contributed to by the increased heat and to some extent the drying that's occurred in parts of California. We also saw as examples the increase in significant numbers of Category 4 and 5 hurricanes. While it's not yet possible to be sure that that increase is due to the buildup of the greenhouse gases, it's the kind of change that the models project should be occurring now and in the future. And I'd point particularly to Hurricane Maria, which devastated Puerto Rico and from which Puerto Rico will be recovering for a long time, and Hurricane Michael, which wreaked havoc on parts of the Florida Panhandle. Another concern, another headline, is that we may be near a tipping point with some of these outcomes. That is, changes that we trigger now, that once they've been triggered, they either occur immediately or will occur over the coming decades or even centuries, but are effectively irreversible, that there's nothing much we can do to prevent them from actually occurring. And the one that scientists have circled back to again and again and again over the last 40 years actually, is the threat of a very large sea level rise due to disintegration of parts of Greenland and Antarctic ice sheets. Sea level rose due to warming largely over the past century, the 20th century, by about 6 inches. It's now possible that a sea level rise of up to about 6 feet, 10 times at 6 inches versus 6 feet, a half a foot, not 10 times, a half a foot versus 6 feet, 12 times, as much sea level rise will occur over this century. And then in subsequent centuries, we could be brought into 30 to 50 feet of sea level rise, all if we pass a certain trigger point, which The exact point at which we are not sure, but seems to be in the same range that these reports, that the IPCC reports covered. Namely, if we go over about a 2-degree warming, we're entering a world where the risk is very high of triggering a very large sea level rise, which might not occur immediately, but would play out partly soon and partly over several centuries. Because we don't know exactly how long you have to cook the ice at those temperatures before they'll collapse, the ice sheets. Another headline, some ecosystems which don't have the adaptive capability of human beings or society are very vulnerable and are essentially on their way out. The report, as many previous reports have, pointed particularly to coral reefs, which are not just beautiful, not just provide a sustainable fishery for many islands and a lot of income from tourists, but are also very rich. They're called by many people the rainforests of the ocean because of all the biodiversity attached to them. There are many other ecosystems that are threatened, perhaps not quite so much as coral reefs, which are right at the cutting edge of sensitivity. And the biggest bottom line in terms of what can be done about it is that basically we're in for more and more of this unless we take transformative action to change our societies in very comprehensive ways to become much less and eventually not at all dependent on fossil fuels, and replace fossil fuels with renewable energy and other options, and run societies that are much, much more efficient as well. Let's have the next slide. A more subtle question is, does it make a difference whether we're 1.5 or 2 degrees? The governments pose this question because their initial assessment of a danger zone was that it starts at 2 degrees, but some scientific information suggested 1.5 degrees may be more appropriate. And in fact, the IPCC report does make it plain that 1.5 is more beneficial than 2 degrees. However, it's also true that neither of them is, as I said before, we're already getting damage, and for some people already we're in the danger zone. No temperature, no additional warming is good. It's all, it's all in a negative direction, basically. And some of the benefit of 1.5 versus 2 degrees both highlights the benefit of staying as low as possible, but at the same time, the limits of what we're currently able to do by emissions reduction. For instance, there'll be less coastal flooding at 1.5 degrees by one reckoning is about a factor of 2. On the other hand, while we will preserve more coral reefs, we might save 10 to 30% of them. And if we let it go to 2 degrees, we might lose 99% of them. But either way, it's a big blow to ocean biodiversity. We will, however, potentially significantly lower the chances of going over that ice sheet trigger. And therein, the value of moving to 1.5 rather than 2 degrees has definitely been highlighted by this report. However, on the negative side, another bottom line of the report is you need very strong, even one would say draconian, global scale emissions reductions of the primary greenhouse pollutant, carbon dioxide, to actually meet those objectives. Namely, to get to 1.5 degrees, you need 45% emissions reduction by 2030 from the current levels. And I can't imagine a world where that'll actually happen. 2 degrees, we need a 20% reduction, more possible, still not easy. And probably we need to actually actively remove a lot of carbon dioxide from the atmosphere that's already been emitted, either by enhancing the biosphere in some way because plants photosynthesize carbon, or by chemically removing the carbon dioxide from the atmosphere, a proposition that many people are actually working on right now at a basic research level, but which remains at this time rather expensive. But there's a possibility we could remove the stuff, then we would be faced with the question of where to bury it, how to get it, how to keep it out of the atmosphere. That's a longer story. It's enough to say this is a technology that's evolving. Nevertheless, even if the prospects of avoiding 1.5 or even 2 degrees are not so great, and I would pose my own personal views, the odds of avoiding 2 degrees are probably in the range of, I don't know, 10 to 30% and 1.5 degrees even less. It doesn't mean we shouldn't try, because every bit of reduction of carbon dioxide and other greenhouse gases keeps us away from a 2.5, 3, 4 degree warming. And a 3 or 4 degree warming is a world that's an ecological disaster. And 4 degrees is socially unmanageable in my view. We just don't have a choice but to do what needs to be done to keep out of that world. So I just want to be clear here. There was a lot of framing, not by IPCC, but by the users of the information after the report that basically, and I'll paraphrase, we're done for if we miss 1.5 degrees or 2 degrees, if we go warmer. But that's not accurate, and it's certainly not helpful, because that kind of message is totally disenabling in terms of action to do something about it. People give up. The reality is we, as humans, have some resources that will allow us, particularly, again, in countries that are well off, to be able to manage and to learn better how to manage some of these impacts. And it's certainly something that we're going to have to learn to do, because some climate change is already baked into the system. So that rather than throwing up our hands and giving up, we should make every effort to come as close as possible to 1.5 degrees or 2 degrees, rather than saying, well, we're all toast, let's have a party anyway, which would be exactly the wrong message. Let's have the next slide. Just some basics very quickly. This is a direct measurement of carbon dioxide in the atmosphere since 1957. Carbon dioxide has gone up about 45% since pre-industrial times in the early 19th century. And this change is without doubt due to human activity, mostly the burning of fossil fuels. Let's see the next slide. On the next one, we see one of the byproducts of this carbon dioxide buildup. That's the warming that's occurred. This is Earth's temperature from 1880 on the left to 2017 on the right. The government's official numbers for 2018 just came out today. It's the 4th warmest year, so it's a little below last year's, and that's because there's a little bit of natural variation due to year to year due to various factors like random fluctuations or a little bit of fluctuation in the sun. But the trend here is absolutely clear, and it's by and large due to the buildup of greenhouse gases. And the next slide. I'm going to talk about sea level rise partly because it's one of the more globally widespread damages that's projected to occur, and also for selfish interest, because it's what I spend most of my time on the research side on. As Earth warms, sea level rises for 3 reasons. Number one, oceans warm, and like any fluid, if you warm it, it takes up more space in whatever container it's in, and the container is the oceans. Number 2, mountain glaciers are melting, adding water to the oceans. And number 3, the polar ice sheets, the Greenland and Antarctic ice sheet, are at their fringes starting to disintegrate, and that's adding ice, in other words, water to the ocean. So sea level is rising. If you look at the next slide, we can see how much it's risen over the past century. Let's have the next slide. So the upper panel shows measurements. The orange, green, and black lines are older measurements in general that were done using devices called tide gauges, little flotation devices, which are located around the Earth's coastline, and showed a rise of about 6 inches over the 20th century. But starting in about 1992, we started getting satellite measurements, which are the red curve, and which are more global in their coverage and show a rate of sea level rise, which is about twice what the rate was during the 20th century. So if you look at the panel in the lower left, the lower right, you see the satellite era at the far right is the big bar. It's about twice as high as the 20th century bar. So there's been an acceleration. And even more interesting, we can indirectly say what the rate of sea level rise was over the past 2 millennia. And it's about 1/10 of what it was during the 20th and 21st century. So you're seeing quite an acceleration, and that has been linked recently to the accelerated disintegration of the 2 major ice sheets. So let's see the next slide. One important feature of this problem in terms of the basics is that carbon dioxide, once it's in the atmosphere, is effectively in a human lifetime irreversibly there, unless, again, these people who are working on what's called air capture, the chemical removal from the atmosphere, are successful. You can't really grow enough plants on the surface of the earth and at the same time feed humanity with agriculture in order to remove 100% of the amount of carbon dioxide in the atmosphere, or even a big percent. You'd probably be down around a 10%, 15% contribution, maybe 20%. And it would certainly help if we stopped current deforestation. But I think we have to assume for the time being that whatever we emit is essentially there for a long time. And the reason can be understood if you use this bathtub analogy. If you make an analogy between the water coming out of faucet on the upper left there into a bathtub, if you say that's like emissions, and if you realize the drain is like the natural processes that absorb carbon dioxide from the atmosphere, like dissolution in the ocean, you can see that you get a level in the bathtub that depends essentially on the competition between emissions, or what's coming out the faucet, and drain, what's going down the drain, or what's dissolving in terms of carbon dioxide in the ocean. So that if the two were in balance, you'd have a constant level of carbon dioxide in the atmosphere. And you can do the experiment in your own bathtub and try it. But in fact, what's the situation we're in is that emissions are much higher than the flow out from the drain, so that the level is constantly rising. And in fact, it's so much out of balance that we would have to almost shut down and eventually completely shut down emissions in order to get the growth, to, the rising level to stop rising, to stabilize and eventually fall. And you can see in the upper right-hand chart some computer experiments that illustrate this, depending on whether we stop the experiment we're doing or slow it down and get off a business as usual curve in 2025, 2050, 2075, 2100, and so forth. You get, at the end of the day, on the left-hand side by the, the right-hand side by the year 3000, quite substantial levels of carbon dioxide. So if we keep carbon dioxide, if we were to soon today do a fast turnaround and start our emissions going down very fast, we could, by the year 3000, get fairly close to pre-industrial levels of carbon dioxide. But that's, that's 900 years from now. In the meantime, we're at elevated levels. On the other hand, if we keep on this course till 2100, the course we're on, and then we decide to do a rapid turnaround, and a rapid turnaround isn't possible, you can't turn on a dime, we would still, in the year 3000, have about 800 parts per million in the atmosphere compared to the 400 we have today, for instance. So we are stuck with this problem for a long, long time, again, unless some of these developments for removing it from the atmosphere chemically become affordable. Let's have the next slide. So let's have a small sampling of the many recent changes besides what I've talked about in terms of heat waves, having general warming and category 4 and 5 hurricanes, or more extremely hot days, heat waves, more extreme intense precipitation and otherwise drier conditions, there's a melting of the Arctic sea ice pack, which lets more sunlight penetrate into the Arctic Ocean and warm it, destruction of coral reef systems and destruction of the Arctic in general, more acidic oceans because carbon dioxide is an acidic pollutant, so when it dissolves, it goes into the ocean. That's just a small headline for what's gone on. There are many more of those examples I can give, and each of those is tied, it is attributed to, it is directly connected with the buildup of the greenhouse gases. The more category 4 and 5 hurricanes we experience, a little too early to say whether that is at the current time connected with the buildup of the greenhouse gas, although we expected the greenhouse gases will in the future certainly make that trend visible in the North Atlantic basin. And then troubling, there's been a slowdown in the post-World War II growth in crop yields as the gains from the Green Revolution run out, and the fact that in some areas the warming and drying due to the change in climate is slowing down crop yields, reducing crop yields. So although we're not threatened yet with a decrease in food supply, it's going to become a concern if the warming continues, with potential for increases in malnutrition and even starvation episodically in parts of the low latitude developing world. Let's have the next slide. Just a picture I took of the melting Arctic ice cap, ironically, on a plane flight back from an IPCC meeting. You can see the leaders in the ice. This was 2014. If that same picture had been taken 50 years before, it would have been a much more solid ice pack. Let's see the next slide. So what about the future? These are projections of, at the top, future temperature compared to, let's say, the year 2000 is the comparison. At the bottom panel, future sea level. There are two big uncertainties in all these projections. The orange band represents basically, if we don't pay attention to these warnings, we continue on business as usual, we'll have a warming which ranges between about 3 and 5.5 degrees Celsius globally over this century. And that's huge. And as I said, that's in the unmanageable category. The orange band about the median red line is basically the uncertainty we have in the climate models. Some models would have it more, have a high sensitivity to the climate and have a more like a 5.5 degree warming, while some have a lower sensitivity for this emission scenario, namely about a 3 degree warming. And then the blue or low curve is if we make diligent efforts and really do everything we can to get in the 1.5 and 2 degree range, we could just about do it. But that, again, it's not going to be easy, but it would involve a world that is, for most people, manageable. For some people, for instance, people living in subsistence agricultural regions which are drying out and getting too hot, are still going to be real trouble. And it will be costly in any event to adapt, even in wealthy countries. In terms of sea level rise, it's basically the same pattern, a sea level rise over this century at a minimum at the low part of the blue curve of about 30 centimeters, which is about a foot, which is twice the rate of the past century, and would be manageable, but would cost. And for low-lying areas like parts of Bangladesh, probably wouldn't be manageable. And the high curve of sea level rise of about 1 meter would be, again, sort of unimaginably difficult to deal with in many places. Let's see the next slide. And that's kind of the good news on sea level rise. This shows you the history of projections of sea level rise. The red bars, reading from left to right, are the projections of sea level rise in meters that IPCC has made in each of its 5 assessments. And then since the 5th assessment, you see a bunch of different estimates in circles, bars, and stars going up on the left. The main point, don't worry about the specific numbers. The point is they run up above 2 meters. So although we don't know which of these is right, and right now I'm involved in the next IPCC report trying to sort it out, the fact of the matter is that the curve has been headed in the wrong direction recently, or an unfortunate direction. Let's have the next slide. Yes, so the warming, this is the way the warming looks worldwide, where redder means hotter, and the top panel, redder is hotter, and brown to orange is not so hot. On the lower panel, we're talking about not temperature but precipitation, and the left panel, which is the business as usual world, shows a lot of blue, which means more precipitation, but it's primarily in the high latitudes. A lot of the low to mid latitudes get less precipitation, and particularly places like southwestern US, the Mediterranean basin in Europe and North Africa, parts of Southern Africa, parts of Australia, parts of South America, and Mexico in particular. So you're seeing drastic changes in, again, agricultural viability in much of the world, in the high emissions world. Again, those are the 2 panels on the right. You can see the intense heat, the red to the very dark red. And you can see those drying brown areas in the bottom panel. And that's what we really worry about. The low emission scenario, again, the one that would get us near 1.5 degrees or 2, would have a lot of warming. These are the 2 left-hand panels. You see it at high latitudes. The Arctic's going to change no matter what, what I'm saying. But fortunately, in that world, much of the rest of the warming would be relatively modest, and the drying would be much less noticeable. Let's see the next slide. Just to remind you what extreme heat looks like and how it would change in the future, there was a heat wave in Europe. There have been a number of killer heat waves in the recent 10 or 15 years. The most notable one was in 2003 in Europe, where upwards of 35,000 people died. If you look at it, you can see a map of that heat wave where the red blotch is. The next panel, panel B, shows you the vertical lines are the temperature in every summer for the last century. And you can see that the lines are densest where that curve, that what looks like what's called a normal distribution, peaks. And then you look all the way over on the right and you see 2003. So 2003 was way, way, way more hotter than any summer during the 20th century. And then you ask yourself, so what do the models tell us about what the 20th century would have looked like if it were happening at the end of the 21st century? And there you see a rather startling picture where you see the vertical red lines in the lowest panel, which are basically the temperature of each predicted summer between 2071 and 2100. And you notice that the median for that, right in the middle, around 22 degrees Celsius, is right smack on what the median was for the summer of 2003. So an unusually hot summer becomes a typical summer. This is for Europe for 2003, and that's the pattern we're getting all over the world. And even if we have a lot more air conditioning, and we is who? Is it rich countries, the poor countries, or some mixture? And even if people are better adapted to extreme heat, it's still going to be the case that you're going to then get some summers like the furthest right-hand one of the vertical lines, which are still much hotter than it was in 2003, because those are the extreme heat waves of the future. And what are we going to do then? So this is a rather daunting picture, and it presents both the risk and gives a hint as to some of the solutions if we don't get emissions under control. Namely, everybody has to be wealthy enough to live in an air-conditioned bubble. Let's see the next slide. I'm going to skip this one. It basically shows that some areas benefit from warmer temperatures because they have a longer growing season, like parts of northern Russia. But the areas benefiting, which are the blue to green bars, by 2090, actually by mid-century, they're far dominated by the red to brown bars, which are the number of areas that are disbenefiting or where agriculture is hurting and crop yields are expected to decrease. Let's see the next slide. Now you can look at the United States in particular. And a recent study, when I was one of the authors on this study, showed that these effects, some of them are going to hit the hottest parts of this country hardest, which is not a surprise because they're already hot. So that with very large increases in percentage increases in heat-related deaths, and compared to current heat-related deaths, and decreases in labor supply. This was kind of a shock. It turns out that even in some situations where the labor is occurring in air-conditioned offices, say, that you do see a decrease in the efficiency of labor. That means essentially people work more slowly or work less hours. And this is particularly telling, of course, for people who work outdoors. And you see this general slowdown in economic productivity, and it's significant. It's of the order of a 3% decrease for the high risk outdoor laborers in places like the Texas, Florida, Georgia, etc. And think about what that means in terms of what it's like to be outside, what it's like for children to be outside just playing. It really means going into a different and not a very friendly world. Let's go to the next slide. Next slide. There we go. We're going to talk about hurricanes and sea level because the worst effects of sea level rise occur when there's a storm where the sea temporarily rises, not just due to the increase in the average sea level, but then you get the storm surge on top of that. This happened in Hurricane Sandy, and there was an extra foot of sea level or storm flood height during that storm on top of the storm surge, which down here where I live in New York City, was the surge was about 9 feet. Well, about another foot on top of that was due to sea level rise. In other words, if the storm had come through in 1900, there would have been, instead of the highest flood level was around 11 feet when you include the tide, so it would have been about 10 feet. And that means there was flooding and damage that occurred that wouldn't have occurred otherwise. And over time, the more sea level rise we get, the further and further inland the flood waters reach and the more damages they cause. So on the next slide, we'll be able to see what the likelihood of these flood increases occurring. This is a little bit complicated. I'm sorry for it. Maybe you don't want to look at the numbers and just believe me. There's a standard marker in the flood business called the 100-year flood. This is a big flood. It covers a lot of territory and does a lot of damage in many places. And it's a flood that has a frequency of return that is, it only happens once a century. That's why it's called the 100-year flood. So that same level, due to sea level rise, assume that storms don't change, which some of them will be reached more and more frequently as sea level rises. And so a place like, say, New York City, which has, right now, if you took the current 100-year flood, by 2050, even in a 1.5 degree world, it's happening about 3 times more often. While if you go to 2100, it's occurring 138 times more often. That means you get what used to be the 100-year flood once a year, even if you're only at 1.5 degrees of warming. And it gets worse from there on out. And a worst case comes from Charleston, Oregon, on the Pacific coast, where you're having, instead of a 100-year flood a century, you're having 7 a year. And then some of the Pacific islands, for various reasons, instead of having a 100-year flood once a century, you're getting a 100-year flood basically on every other tide cycle. You don't even have to have a storm, just that several feet of water level change brings the water inland. And that's because these islands tend to be very flat, and most of the time they're not exposed to very big storm surges. So this is a big change in risk, and it means every place along the coast, from Boston, from Maine, all the way down to Florida, around the Gulf Coast and to the Pacific Coast, will need to spend a lot of money if the bigger sea level rises come about. But even these relatively modest warmings, which are creating a relatively modest sea level rise, not the 2 meters that we were talking about being possible before, are going to entail a lot of damage. We have to be ready for that. Let's see the next slide. Now, in terms of tipping points, which I mentioned before, and again, the real risk is the major loss of one of these ice sheets. They contain a lot of ice. The Antarctic ice sheet, the western part, contains 5 meters of ice, but the eastern part contains 52 meters, that is sea level rise equivalent. If they all disintegrate, the total disintegration would raise sea level. Therefore, if it were Antarctica, by 57 meters, there's another 7 in Greenland. Luckily, most of East Antarctica is not very vulnerable to warming, but enough of it is vulnerable to warming so that the ultimate possibility, if we warm greater than 2 or 3 degrees, could be in the range of about 15 meters or about 50 feet of sea level rise, not happening immediately, spread all out over the course probably of several centuries, but with the potential for a couple of meters or more within this century. And we know this partly because the last time Earth was as warm as it's going to be in the middle of this century, we know that sea level was 6 to 9 meters higher. And we know that that extra water in the ocean came from Antarctica and Greenland. So it's not just a matter of model projections. We know this is the way the ice sheets behaved in the past. What we don't know is how fast this will play out. In our best guess right now, you only get up to maybe a meter or 2 in this century. Going slightly beyond that, we're deeply uncertain about how fast the sea level rise would occur. It could occur quite fast, it could occur relatively slowly, but the ultimate cost, again, to just keep warming these ice sheets, is probably something on the order of 50 feet of sea level rise. Let's have the next slide. And that's what 6 meters look like. 6 meters is what you would get if you lost most of the West Antarctic ice sheet and part of the East Antarctic ice sheet. That could happen, not immediately, not this century, but over the next 2 or 3 centuries in the worst case projections. The red parts are underwater permanently. Let's see the next slide. So let's talk about what's to be done about the problem in the remaining few minutes I have. These are the big sources of emissions. The primary one, this globally, the 35% is from the energy sector, which means basically electricity generation, which is dominated globally by burning of coal, oil, and natural gas, with lesser contributions from agriculture, including the fossil fuel that's used in agriculture and decaying and the release of methane and nitrous oxide from applications of fertilizer and manure to soils. Industry directly uses a non-electric power, electric power already counted for. Transport like cars, that transport number is bigger in the United States, by the way, and building envelopes like heating and cooling, for instance. Let's see the next slide. Now, how are you going to cut those numbers down? This is what you would need to get to the 1.5 or 2 degree objective. We need to make, and I'm going to talk specifically thinking about the United States at this point. We have a very dispersed pattern of settlement. That's why we use a lot of transportation, a lot of cars, a lot of gasoline. And we need to, if you're going to achieve 1.5 and 2 degrees, that has to gradually become more compact, more efficient, so we don't need such a big, with people commuting for an hour or an hour and a half in their car with one driver every day. Electric power production needs to become more efficient and needs to be, eventually you got to get rid of coal, and it's got to be generated by probably renewable energy. More efficient consumption. There's inefficiency throughout the system, running from the way you use electricity to the way you eat. It's been said many times and proven that high red meat diets are big in terms of the greenhouse gas emissions, because you're taking grains and converting them gradually into meat. And that process is very, very inefficient because you're feeding cattle instead of human beings, not directly feeding human beings. So that's a change which would be very, very helpful. And there are other inefficiencies. Our society is rife with them. We're half as efficient as Europe and Japan are in use of electricity, for instance. And these kinds of changes are not big technological innovations. We have the technologies to do most of this. They're changes, however, that require great improvements in governance, the way we organize ourselves politically. I don't think that shouldn't be a surprise to anyone. You can't have something going on like one administration all of a sudden putting in a terrific regulatory regime, and here I'm putting on my citizen's hat rather than my scientist's hat, and start a progress on greenhouse gas emissions, as the Obama administration did, then have the next administration come in and try to reverse the whole thing. And maybe the next administration comes in and reverses it the other way, and then the one after reverses it again. We're never going to make any progress that way. But you also need evolving social norms. So you need, in order to do things like change diets, that's mostly a matter of preferences. So it's a combination of governance and norms, every bit as much as it is about evolving new technologies, because by and large, we have the technologies to get most of the way there. Let's have the next slide. So what would I do if I were in charge? And it's probably a good thing I'm not. What I do is, what we should be doing is ending coal, working to the end of coal and the decarbonization of electricity and a move towards renewable energy. And that is going to have to, it can be started at the state level, and a lot of progress can be made at the state level, but eventually you need a national price on carbon or some system which disincentivizes high carbon fuels, first coal and oil, later natural gas once it's served its bridging purpose. Because it is a relatively low carbon fuel, at least compared to coal. We need to modernize the grid. The electricity grid can be modernized, building up from the state level, eventually a federal role, in coordination with implementing new technology for storage of energy. It would make it possible, if you have a smart enough grid, to manage a large influx of the ever cheaper renewable energy. The real revolution that's happening, of course, is renewable energy. Wind and solar is getting cheaper and cheaper all the time. If that happens, it will be possible to electrify transportation, get rid of most oil as a fuel. Again, price on carbon, there's a federal role that needs to be played there. The push at efficiency, particularly in the electricity sector, is primarily in this country a state responsibility. And again, many states have gone quite a long way on that. Reversal of deforestation, which ultimately could stop about 15% of carbon dioxide emissions, is a matter of global cooperation and finance. It's always done at the international level mostly, aiding developing countries who might not have their own enough resource to make the choice about keeping their forests intact. And it's everybody's responsibility, all levels of government, to enhance adaptation. It's been paid not enough attention, and we're going to need to pay attention to it because a lot of climate change is baked in at this point, no matter what we do. Let's see the next slide. And so I would translate this into 5 larger scale goals. We have to figure out how to communicate about this issue better. Now, again, there's some hope that with these unfortunate, disastrous events that people are starting to get the message, but you know, it's not easy with this complex problem, not just scientifically complex, but complex politically, complex technologically, for people to understand what's going on. And scientists often talk in a way which is even counterproductive in some sense. All of us have to get better, all of us who are interested in communicating with the public, in communicating these complexities better. We need better leaders. You know, with the current kinds of leadership we have, we're never going to get anywhere, except maybe walk backwards. There's a lot of generational energy out there, where, however, partly in response to the current leadership, at all levels of society, there's a generational change happening. Young people, you know, they live and breathe this concern. And that is an opportunity to organize. Get out there and really take advantage of this window of opportunity where people are paying attention to the issue, and you have a rising generation that insists that something be done. And there's work to be done at all levels of government. No level of this problem won't be solved without the active engagement at all levels, running from the community to the international level. There's opportunities for everybody to work on this. And perhaps most difficult, I don't know how to do this. If I had a clue, I would tell you, but combating what may be a growth or may have just simply been the way it always was in anti-science attitudes in society. Because these are complex problems which require, if everybody doesn't have to understand climate change at the basic level, they at least have to respect that there are experts who do understand it. Let's have the next slide. And I think this is the last one. The more we delay, the harder all this gets, and we'd be faced with very unpleasant choices. Again, carbon capture, air capture, we're chemically removing carbon dioxide from the atmosphere and burying it. It's not affordable at this point. It may one day in the medium future become affordable. We'd have to put a lot of R&D money into making it affordable. I think it's a good thing, but we're never going to be able to remove all the carbon that way. It never is going to be 100% of the problem. For one thing, finding enough place to bury it effectively and developing a world where, you know, where we can remove it and bury it is not going to happen in a decade or two. That's a very slow process, and we can't rely on it. In the meantime, we need to rely on renewable energy. Biomass, we may be faced with a crunch between the need to preserve forests, the need to preserve biodiversity, the need to use some biomass for fuels like biofuels versus food production. We can't do it all. We can't square that circle. There may be unpleasant decisions that need to be made, which will, if we don't get renewable energy in place fast enough, may prevent us from getting as close to the 1.5 or 2 degrees as we need to get. Nuclearization of the energy supply. Nuclear fusion, fission power has not taken off the wave 60 years ago. Its promise held, and there are multiple reasons for that. I think the industry has made a bad mistake by not pressing for the development of really clean, safe technologies. The technologies that are out there now are are dangerous from the potential proliferation point of view. It's not clear we can ever develop a nuclear technology that doesn't have that threat. And I personally wouldn't want to live in a world where there was a nuclear power plant. Every place is a power plant today, because it would just open up all kinds of possibilities of unmanaged wastes, too much waste that can be diverted for the creation of weapons, and also there are, of course, safety risks. Then there's the really unpleasant choice of geoengineering the amount of sunlight, essentially lofting little mirrors to reflect sunlight. It's been discussed many times, people work on it, but it has all kinds of side effects which would be unpleasant, undesirable, and eventually unmanageable. And then there's the fallback position of just, okay, giving up and testing the limits of adaptation, and that's the worst choice. That's a world I definitely don't want to live in. So the bottom line is, we shouldn't be crying about this. We should be getting out there and working. We can get as close. We can still have a chance to get to a 2-degree limit. I personally am skeptical we'll get to 1.5 degrees. The 2-degree world is a heck of a lot better than a 4-degree world, and it's a world we can all manage to live in. But we need to be ready for the fact that even the 2-degree world has some unpleasant climate impacts. Thank you.
Thank you, Michael. That was great. We are going to go to the questions. We have about 10 minutes, and we have about 32 questions. So let's get started. The first question, this is from Larry, regarding carbon pricing. Most economists and many national and international organizations think that carbon pricing is a key part of the strategy we need. I'm sorry, it's moving around. We need to adopt. But some environmentalists, parentheses, not me, think that any market-based response is either doomed to fail or is inherently imperialist. Your thoughts?
I think a solution to the problem, a full global solution, will involve using all the implements we have at our hands, all the tools in the policy toolbox. Yes, in some places, there will be a price on carbon. There is already in some places. In some places, there will be strong regulation, the way the Obama administration started to implement regulation. In some places, there are going to be partially voluntary programs. So there's going to be, we're going to use everything, and if we get too theological about it and throw away any one of those things, we're throwing away opportunities to be effective in one or the other country or one or the other state. So I just like to see a lot of experimentation. I'd like to see us try everything, and at any particular time be using the thing which is most effective, and that's determined by what the, not just economics, politics of the situation are.
Okay. The next question is from Eben. How do you suggest phrasing a, quote, hedge on the, quote, we're all going to die in 12 years that still keeps people motivated to act?
Well, it's an interesting question about, first of all, I don't believe it. So you're not going to get me to say, yeah, we should use a message, which I think is untrue. There is a balance between motivating people by emphasizing the worst part of a problem versus motivating them or demotivating them versus motivating them by underscoring the opportunities. My own inclination is to be frank about what the risks are, but also, as I did today, try to talk about the opportunities. We can transform our economy into something that operates over the long term better because we're not wasting energy, and people are, we make transportation easier for people by encouraging more compact development. We rely on renewable energy, which doesn't entail all the awful risks related to coal mining, coal burning, air pollution from coal, or nuclear proliferation, for instance. These are decisions which affect not just the climate, but ripple on through our whole lifestyle. And those are where that's the positive nature of where the solution lies. So I view this as a bad deal that we're going to dig ourselves out of and wind up in a world which will have certain negatives for the climate for a while, but ultimately will point us in a much better direction for the future in a whole number of ways.
Thank you. The next question is from Adam. He says, can't grow enough plants? What is the science behind that?
So you have to take that in the context of all the things we use plants for. First of all, to capture all the carbon dioxide that was emitted over the last 30 or 40 years in trees and keep them standing would require an area like the size of Australia. So there's a lot of area on Earth we would need for this. We got to use that area for other things. For instance, a lot of people are relying on the thought that biofuels might work. I have some doubts, but biofuels, might be useful, for instance, for aviation, where there aren't going to be good alternatives. But you need land for that, and you need land which otherwise would be used for storing carbon or growing food. Even more important, and these things are going to clash against each other, and you can't satisfy all the demands. Or maybe you get enough biosphere for food, enough forest for food, and enough to store 20% of the carbon reduction you need. But then what happens to wildlands? What happens to biodiversity? We can't rely on the biosphere to really take us out of the problem, although it does. We should start by reversing deforestation, and then any further increment above that is just a plus. I think the numbers, an honest analysis of the numbers, show we're not going to sort of solve more than 20 or 25 or maybe 30% of the problem by relying on the biosphere. But it's not like I'm ruling it out. The biosphere is part of a solution. The more we can squeeze out of that, the less we have to do on some other front.
All right. This question is from Beth. New England states are undergoing increases in deforestation to create a biomass hub for export and regional unhealthy boilers in schools for heat, and in exchange for large solar arrays in a number of towns, whereas these same intact second growth forests could sequester significant amounts of CO2 at a relatively low cost. Ditto by the USDA, USFS. How can citizens help stop this dangerous trend?
Yeah, well, this, you have to look at every situation individually. I just made a sort of a large-scale statement about the problem as a whole, but making a decision on what a particular land use is good for in the context of trying to solve the climate problem and protect forests, et cetera, is really a local decision. I can't make a sweeping statement, except that, local people like you who are operating locally know the local situation, have access to experts who can analyze it. You need to weigh and balance all these trade-offs together. And, the idea of logging large parts of New England now that the forests have grown back and exporting the stuff doesn't make a lot of sense to me, but that's off the top of my head. And I really want a forestry expert to be looking at the particular situations you're talking about.
Okay, the next one is from Anne. What criteria should we apply to our leaders? What should we insist on from a candidate we support? How would you describe that criteria?
I would insist on honesty to begin with, which is in short supply today. I would support a candidate who shows a respect for expertise, technical information, science. I would support someone who surrounds themselves with advisors who are also honest and respect technical understanding. But at the same time, people don't get elected, or they shouldn't get elected, unless they understand the needs of people. As I said, we're going to have to do a lot of climate adaptation. We're going to have to understand how people are experiencing the climate change problem, or will experience it, where they live. So leaders that are operating at some high 20,000 foot level, but don't seem to understand the challenges that the typical person is going to be confronted in this new world, those are not people that are going to be particularly useful. And that goes for not just adaptation, but the emissions reduction. If I said sort of cavalierly, we got to get rid of coal, but that's premised on the idea that the communities that are dependent on coal can't be just left out in a wasteland. They have to have opportunity. We have to take care of them also in ensure a transition for them and their children, which is a successful one. Because if we don't, they're going to be in the way anyway. They're not going to let this happen. So transformation and people who lead transformation have to make sure that there's not only an overall benefit for everyone, but that you're not leaving people behind.
Okay. The next question comes from Ray. What do you think of the Bipartisan Energy Innovation and Carbon Dividend Act? And for people that don't know it, just tell a little bit about what that is.
Yeah, so it's one idea among many of price on carbon, which would take the details on that particular act I'm a little shady on right now, but as I recall, it would pass some of the revenue from the price on carbon back to people. I don't remember whether it passes some of it into an increased R&D budget to keep the price of renewable energy going down fast as it has been. But it's one of a number of price on carbon suggestions which have merit. And again, price on carbon has to be stacked up against regulation and other ways of controlling greenhouse gases. And all of these tools in the policy toolbox have merit. I think eventually, my own view is we do need something which is equivalent to a national price on carbon, but whether that price will wind up politically saleable and be high enough so it'll get the job done, I have my doubts. And that's why these other methods, like old-fashioned command and control regulation, are still going to be needed.
Okay, I think this is going to have to be the last question. And then we will follow this up with information on how to get the recording, which several of you have asked about. So the last question, would you speak about carbon sequestration in the soil?
Yeah, there's been a lot of, soils have carbon in them. They're better off when they have carbon in them. There's been a considerable amount of attention in the scientific community on ways to enhance the carbon content of soils. And again, it's one of these measures that's a good idea. It would be good for the farmers too, for instance, but it's not, nobody has proven yet that it's a big chunk of the solution, something on the order of 25 or 30%. So the amount of it that ultimately gets done, if you're just looking at it from a cold-hearted point of view, you stack all the benefits of improving soils up against, the price of solving the greenhouse problem using other approaches, and you make some decisions about how much effort to put into it. I'd say the question is unanswered about how far we could go with it. It's promising. I'm glad it's there. The troubling side of it has been proposed for a long time and hasn't gotten nearly as far as we had once hoped. I keep a somewhat skeptical but not dismissive view of it.
Okay, great. Now we're going to go back to Lana, who's going to have some parting remarks and thanks to you. So, Lana.
Well, I'm going to jump right to the main question of how can people get a copy of the webinar. And this is the answer to that question. If you're still on, you will receive an email from the League of Women Voters, lwvma.org, with a link to the webinar, information and some related materials. And eventually and at the same time, we will have that material posted on our website for general public consumption. So again, I said that you'd receive an email from the LWVMA. It'll be from the League of Women Voters of Massachusetts, I believe, or lwvma.org. Anyway, so I hope that answers a question that was quite frequent during the broadcast. Well, that was a huge amount of information. We had many, many excellent questions, but we have a time constraint, and I have to say that this concludes our webinar program, and I want to thank you, Michael, for helping us understand the key findings of recent reports and the most meaningful actions we can take to mitigate the worst impacts of climate change. None of the news is good, but there is something that we can do and that we absolutely need to do. I want to thank also the 450 plus members of the league and the public from across the country who joined us today and for your interest in this critical topic. We urge you all to stay informed and stay engaged, and I'm going to borrow from Michael now, organize. Again, that's it. This concludes our broadcast. Thank you again for joining us. Bye.